Hello, everyone. We'll just give it a couple minutes to let people continue joining, and then we'll get started. Hello, everyone. Thank you so much for being here. On behalf of the Environmental Finance Center Network, welcome to today's webinar on smart solutions for small systems, harnessing technology for efficiency, compliance, and sustainability. My name is Owen Volk from the Syracuse University Environmental Finance Center. Before we begin, we're going to go over a few logistics and then we can get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box at any time throughout the session. We will be saving your questions for a facilitated Q&A at the end of the presentation. After the webinar, you will receive a follow-up email that includes a link to the recording and any other information that you may need. You can also download the slides from today in the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for this session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date. If you have any questions or need assistance, please contact smallsystems@syr.edu. Now for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and finance capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. One of the many ways EFCN can support your community or utility is through our free funding application support. Struggling with an infrastructure funding application? Falling short on project funding? Not sure where to start? EFCN is here to help. Submit a request through the link in chat to receive tailored support based on your project needs. And on that note, we can get started. I would like to introduce our presenter for today, Danish Kumar, Climate Change Program Manager at the University of Maryland Environmental Finance Center. Welcome, Danish, and I will hand it over to you.
You. Hi, and welcome everyone. Today, we'll be exploring how small system wastewater treatment systems can use smart technologies to improve efficiency, ensure compliance, and promote sustainability. Thanks, Owen, for going through this in pretty much detail. So I'm Danish Kumar. I work as a program manager at Environmental Finance Center at University of Maryland. We are also one of the partners of Environmental Finance Network, and we provide education and training, technical assistance, research and policy analysis. And we also facilitate community outreach and facilitations. We have 2 flagship programs on Municipal Online Stormwater Training Center, and then Sustainable Maryland, which certifies local governments within the Maryland jurisdiction. So I just want to again point out, like the free funding application support, we have this small system technical assistance as well, and a lot of educational resource on EFCN website, which is also linked here, as well as like you can, if you are looking for some sort of technical assistance, we have a wide variety of partners in the EFCN network, and you can go to this website and click on Get Help, and you will be connected with a relevant service technical assistance provider. And also there are a lot of existing educational resources. So if you are looking to know something, you can go onto this website and see where we have done trainings or existing resources like blogs, podcasts, and webinars that are previously done by the EFCN team. And if you have any needs or query within region 3, you can call or email me and our team head here at EFC. Again, this is just my good picture. And then just the run of the show, we'll be just starting with introduction of like what are some common challenges that small wastewater treatment plants are facing, and then what are some small like smart infrastructure technologies and terms used in that, those benefits. We'll talk about benefits, and then success stories that are on this spectrum, and then how you can start doing or implementing these smart infrastructure technologies into your wastewater treatment system. And then we have a Q&A. Again, Justin, I know a lot of you know what WWTPS is. It's just wastewater treatment plants, and written as short form as WWTPS. So first, we'll have an initial poll just to get the feel of the room. Owen, can you please run the poll for me?
Yep, absolutely. So we'll give it about a minute, and after a minute, I will close and give the results. Okay, not about 10 seconds. Okay, so our results for our first poll. Obviously, the question was, what is the biggest challenge your small wastewater system is currently facing? 52% said aging infrastructure. 15% said staffing shortages. Rising compliance costs was 7%. Lack of funding for upgrades at 20%, and then climate risks at 5%.
Thank you, Irvin, for sharing the results. Yeah, aging infrastructure is but definitely a concern, and as well as a lack of funding for upgrades and staffing shortages. So we'll just discuss a little more on that. What's the importance of small system infrastructure systems? Small systems protect health and environment in rural and underserved areas. In the US, wastewater treatment is primarily handled by publicly owned treatment works with over 16,000 facilities nationwide. And majority of these facilities, around 80% or 12,000 of them are small, serving less than 10,000 people. And then there is a lot of small decentralized systems which serve 20% of the US population. So this small infrastructure, small system infrastructure is a major component to maintain public health and environmental protection of our water systems. So as we said, we are experiencing aging infrastructure. Many of these systems rely on outdated equipment and pipes. There is staffing shortages as well, limited personnel to manage operations and compliance. And we are hearing more and more stories on how a lot of people are, how a lot of personnel are going to retire soon from this industry. And then there's all again, rising compliance cost for high expense upgrades, monitoring and reporting. We are seeing increasing climate risk like floods, drought, and then increased precipitation. And within the short duration, which also like have a impact on wastewater treatment plants. And then resources, with there are lack of financial and technical resources to meet those compliance and regulations requirements. And obviously you have like the small wastewater infrastructure systems have a critical equipment that can fail, and we have a community to serve. So we have to look into these challenges and work for our community. Again, these like there are challenges that lead to issues like exceeding limits of pollutants, of oxygen demand, suspended solids, pathogens, nutrients, and then with that, which leads to reporting issues because of staffing shortages. Many operators fail to submit required discharge monitoring reports, and then which can also lead to environmental impact with violations in surface water quality and affecting the drinking water supplies. Regulation and compliance, we are seeing that there can be some change in those regulation and compliance, and then small systems have to adapt to evolve these adapt to these evolving regulations by staying informed and training staff and exploring some innovative technologies. Another big aspect of that is financial implications of non-compliance. And with those regulations, it can lead to significant financial penalties and operational disruptions as well, which highlights the need for prioritizing smart infrastructure or smart changes, which are small, but they can have a huge impact to implement those, to fulfill those regulatory requirements. And I'll just share this chart or graph of enforcement and compliance history that is from the EPA website. We can see that there are a lot of penalties that are assessed in millions each year. In 2024 alone, there were $43 billion of penalties assessed on all infrastructure systems, and there were minor facilities which were charged, assessed with $28 million dollars of non-compliance. And then non-compliance is related to really small things like including exceeding levels of oxygen demand substances, total suspended solids or pathogens, and total residue chlorine. So we need to focus more on reducing this cost. And in addition to this, many small systems fail to submit required discharge monitoring reports, which can be automated as well, and submit incomplete or inaccurate reports. So we'll talk more how some of these systems can be automated with the use of smart infrastructure technologies. So our goal today is to get you familiarized with the terms that are used in this spectrum and new technologies that are being used by showing some case studies in the space of wastewater treatment, which with all these new technologies coming up. Also, just some basic terms that are used in this spectrum. Smart meters. Smart meters can monitor pH levels, or sensors can also monitor that and monitor water usage in real time and identify or reduce water losses as well. And then sensors are used to track water quality parameters like pH, DDS levels, and it can respond rapidly to any deviation or issues when they are connected to IoT, which is called Internet of Things. This is a centralized systems which connects devices and sensors to a centralized system. It can provide you real-time data collection and analysis, and then you can automate with the help of smart meters, sensors, and IoT. You can automate treatment systems, utilize sensors and actuators, which is also a term, or thing used in this and leading to reduced energy and chemical consumption. So actuators are like physical devices which can be used to automate valves, airflows, and aeration controls. And automated treatment, I just like to mention that it's like it utilizes sensors to adjust processes, leading to reduced energy use and chemical consumption as well. We have another poll.
Okay, next poll is up. Give it about a minute. Responses came in quick, so we'll give it another 10 seconds.
Perfect.
Okay, so for the poll, the question, how familiar are you with smart infrastructure technologies like IoT sensors or automated treatment systems? Responses, 15% said they were very familiar and they're already using them. 54% say they're somewhat familiar, heard of them, but aren't using them. And then 31% said they are not familiar at all.
That's amazing. We have really good mix of the audience, and our goal is today is to get you familiarized with some of these technologies and how show you some case studies as well. So we'll just like see some benefits of using these smart systems. So mantra today is to like small system can be a smart system. We can have pump station valve and aerator monitoring on spot, early warning signs. We can have environmental oversight to monitor temperature, humidity, flood sensors. So you can like make proactive interventions, and then we can also monitor the equipment and have like preventive protection against equipment damage by detecting overheating, pressure anomalies. And then the best part of this is like communication, because this is connected to Internet of Things, basically simply internet. So you can get the instant notification and messages, so that you can like instantly uh, do some preventive measures. So these smart systems can have enhanced monitoring capabilities. The integration of sensors and IoT devices allow for like continuous monitoring of wastewater parameters, and which enables timely interventions and improved compliance with environmental regulations, as well as it helps in data-driven decision making. With a lot of data that those sensors collect, you can predict maintenance needs, enhance your operational efficiency on how much chemicals are being used and what's their levels, and you can do some proactive management strategies and improve your overall efficiency and sustainability. And this can also like be useful for environmental management, ensuring compliance with regulations while minimizing ecological impact through timely interventions with the data collection that you are doing with the sensors and smart meters. So by continuously monitoring parameters such as flow rate, pH levels, dissolved oxygen, and IoT devices can identify and trigger alarms, ensuring that necessary actions are taken. You will be doing fewer site visits because you are getting the remote data information, and you can pinpoint exact failures based on the information from sensors and analyzing it. And you can dispatch right person for the right job with the right parts and eliminate the guesswork from it, and then improve your response time and be quicker to responding this. So the bottom line here that I want you to take away is like you can save on labor cost, reduce downtime, and stay in compliance all at once with remote monitoring by using these technologies. And that's the best time, because we have aging infrastructure, is to set up strong like remote monitoring before something goes wrong. And as we are already deteriorating infrastructure, this is the best investment that you can make as well. So again, I've mentioned before that this provides real-time data utilization. You can get continuous data collections from IoT devices and get operational insights and make timely adjustment. You can have predictive maintenance strategies, reduce downtime, and reduce operational cost, as well as like you are resolving issues before getting into the significant problems. And then integration of Internet of Things and automation promotes sustainable practices by optimizing resource use, reducing waste, and supporting compliance requirements. These sensors and real-time monitoring parameters monitor flow rates, pH levels, pollutant concentrations throughout the system, which allows the utilities to respond to an issue promptly. And then there are optimization benefits as well. You can help reduce your energy consumption as well. And then quick response, again, with all these instant messaging services that they provide, you can get and resolve your issues within the wastewater systems quickly. So this provides you streamlined process management. Automation enables real-time adjustment to treatment processes and while minimizing manual intervention. And then you can also have improved resource allocation like automated systems, optimize use of chemicals, energy, leading to significant cost savings and sustainability in wastewater operations. And it provides you data analytics of with the dashboards, with all the data that you are collecting. You can improve your decision making and operational reliability. You can save and resource optimize with reduced labor cost. It minimizes the need for manual labor, and which leads to significant savings on overtime or staffing expenses. Again, efficient chemical usage can also save you cost by smart dosing systems, ensuring like precise application of chemicals, like how much amount is actually needed, and reducing the waste and overall chemical cost by checking the pH levels and the TDS level of the water, and then improving monitoring capabilities, decrease the likelihood of violations, avoiding fines, and promoting long-term financial sustainability. So I'll just briefly talk about different components that are used in this system. Uh, Obviously, there are like data transmission technologies, data analytics, and dashboards, and then which provide you alerts and notification. So system monitoring and operational tools, these are basically the tools that you will be using to improve your operational efficiency. First one in that is real-time continuous monitoring. It obviously just uses remote sensors to provide real-time insights into the system conditions and operating status. You can install sensors throughout the system to collect data or information on flow, water level, rainfall, and other data. These sensors can communicate their data to a central database connected via the Internet of Things, Internet, IoT, and then you can use this to dial in maintenance intervals, identify potential problems, and inform decision making for capital projects. And these tools provide can make day-to-day operation systems and maintenance more informed, efficient, and automated. This is an enhanced version of this decision, which is called real-time decision support system. So it provides you a software capabilities along with those sensor data that is coming from sensors, and this combines hardware and software both, which are added to wastewater systems to inform operational decisions. Sensors and other devices can measure system information, which are connected with the wireless networks that transfer the collected data to a software tool. The software that then analyzes the data and provides you analytics that and produce a dashboard to see what are the actionable information from the system operator. And then these are also connected with supervisory control and data acquisition system, SCADA, which a lot of small systems are implementing these days to receive and communicate data and control commands between central and remote locations in real time. These are real-time controls to make changes into your infrastructure systems as well. So regardless of size or complexity, real-time control can include real-time flow or level monitoring device, a computerized system again to analyze data from controls to inform decisions, automated controls. With that, you can have an extra feature of controlling the gates, weirs, valves, or pumps, and you can install in one place or in your whole system depending on your needs. But it is ideally recommended to have a initial pilot first and then work towards the whole system. And a typical real-time control is again automated with real-time decision support system, which can help manage the volume, route access flow, and storage it to or a treatment facility. And we'll see how all of these are implemented in real life when we discuss the case studies. So these are like system condition capacity tools. These are more geared towards like how you can improve your existing infrastructure. So these technologies are used for sewer system inspection and can help operators identify defect and failures. And these have been like long in this industry for assessing system condition and are really widely used. But there are also newer tools available like laser-based scanning or digital scanners as well to provide you more detailed data and get data where it's not feasible to get it. And you can use these smart technologies to capacity to handle flows and loads and identify any limitations of these systems. Again, this is an upgraded version of the previous. It's condition assessment software and analytic tools. These tools automate some data collection and evaluation process to provide more informative outputs, as well as our better outputs can lead to like system issues such as inflow and infiltration. And then this condition assessment data analytics can help be integrated with those systems, EAM systems, to optimize asset cost and inform capital planning in the long term. Um, these modules are again used with real-time controls on flow dynamics, capacity, condition assessment, and performance to help utilities optimize operation and maintenance of existing infrastructure. And they are also like more accurate due to real-time monitoring by connecting those with sensors or smart meters, and then improve condition assessment technologies like laser-based scanners and advanced analytics. Because of increasing use of technologies and increasing improvement in those technologies, these models have become relatively cheaper and more user friendly over time. So they are like easier to use as well. Hi, we have another poll.
Poll is up. We'll give it about a minute. Okay, another 10 seconds. Okay, so results for the poll. So the question of how does your basic system currently monitor wastewater operations? 15% say manual checks, 56% say basic sensors, 21% have advanced monitoring, and then 8% say we do not have a monitoring system.
That's really amazing. Like a lot of people are like, a lot of systems are having basic sensor or having like advanced monitoring systems. That's really amazing to know. I was not expecting that. Thanks. Yep. So we'll just see the case studies of how these technologies are implemented these are more like geared toward infrastructure improvements because already those small sensors are like easier to install or easier to use as well. So this is a case study on cutting cleaning times and cost. This smart technology has helped La Mesa, California, to retain a preventive maintenance cleaning routine while cutting cost and improving productivity. So what the city used to do was like it used to have 100 hotspot, but then they turned into a smart solutions for those 100 hotspots to better pinpoint where cleaning was really needed. And then they started a pilot project using real-time remote monitors to assess site conditions. We can see one of the examples in the figure here as well. So based on that pilot project, the city cleaned 12 times during the pilot, which was an 80% reduction from its prior schedule. So this is a very good example of how it can reduce your staff time or how it can reduce your maintenance cost as well for your infrastructure system. So the real-time remote monitors helped save more than 19,000, and it helped staff to focus on other maintenance needs and prevent sanitary sewer overflows. So all these case studies that I'll be explaining today or showing you today, they are all from EPA's website from their different programs. So this is another example from California, which operates a small sewer system southeast of Los Angeles Airport. They installed real-time remote sensors across about 2.5% of the sewer systems, around 50 manholes. And those sensors were wirelessly connected to an analytics tool through Internet of Things or Internet simply that allows the utility to see the water levels in those manholes and in the system pipelines in real time. So since installing that system, the city has saved almost $2 million in fines and mitigation costs related to the sewer overflow. So this is a really good example of how you can see the real-time change and uh, work your way accordingly for the wastewater treatment of the water that is incoming. This is a case study from South Bend, Indiana. They installed 120 smart sensors and actuators that trade available conveyance capacity in real time. Again, similar example like the previous one to avoid flooding and overflows. And since implementing this program, they have saved about $1.5 million in annual operating and maintenance cost. And because we have a lot of big issue of aging infrastructure, they have avoided 500 million in avoided capital improvements as well. This program has also eliminated dry weather overflows and reduced combined sewer volumes by more than 70%, which is huge. We can see that in the graph that since the real-time control system was implemented in 2012, the volumes of overflows have reduced significantly throughout the years. And the best part for this is like E. coli concentrations in the receiving water have also dropped by more than 50%. So it has a lot of more or dual advantages, not only just improving your infrastructure system, but enhancing the water quality as well. And this is a case study from Louisville. It's a significantly bigger wastewater treatment plant, but I believe that all these smart system technologies can also be downsized into this for smaller utilities as well. So they installed real-time controls to optimize wastewater conveyance, storage, release, and transfer based on available capacity of their plant. And then they minimized overflows and relieved stress on the treatment systems because of the data that they had. And as a result, again, they have reduced sewer overflows by 1 billion gallons, which saved them about $117 million from the original long-term control plan, which was like a 58% reduction in capital investment, which is a huge amount. Again, if we compare it with the small system, it can be a huge saving component as well. This the case study is from Indiana. They implemented a real-time decision support system using sensor networks, real-time monitoring, and artificial intelligence, which we hear a lot about nowadays. So we can see in the graph, they can see the available capacity at the wastewater treatment plant to an hour in advance, which is really huge, with recommended pumping rates as well. So they can reduce their energy use or make their plant more energy efficient. And because of this program, Evansville has reduced combined sewer overflows by more than 100 million gallons. And then it estimates a saving of whooping like 95%, which is huge. And this is a really interesting case study. Again, a slightly bigger wastewater treatment plant. But again, we need to acknowledge that it can also be downsized and used for any small wastewater treatment plant as well. They implemented this program in Ohio for more than 200 combined sewer overflow outfalls. So what they did was they installed these devices, which are shown in the figure. We can see that a remote valve for basin control is installed, and then there is a smart manhole cover and an open source sensor node for distributed measurement and control of the flow and water that is coming. This is implemented under SCADA, supervisory controlled and data acquisition system, and to create synergy or symmetry with the other utility components and maximize their treatment capabilities. So they have their whole system connected. And because of this, their overflow volumes have reduced by 247 million gallons annually. And they have again saved a lot of money in capital improvements and fines from non-compliance. This is an example from infrastructure maintenance with technology. They had a problem of 3 miles of trunk sewer with capacity issues causing basement flooding, and they identified pipe collapses and solids buildup and gather accurate data for cost-effective cleaning. And they got the results that because of this survey that they did with the technology, uh, the survey was completed in 11 days, really sooner than they expected, and it resulted in 40% lower bid cost because they had better data on the maintenance that they had to do and the cleaning project. Because of the data they had with all the digital laser scanners, it was completed faster than expected and also reduced the traffic disruptions. We have another poll.
Yep, launching the poll right now. Okay, about another 10 seconds. Okay, so results for this poll. So the question, what's the biggest barrier to adopting smart technologies in your system? 56% say high upfront costs, 25% say lack of technical expertise, 8% say uncertainty about ROI, and 11% say resistance to change.
Okay. Yeah. Obviously, cost is a really major concern for everyone, and then obviously this is a new technology, so we have not uh, we have a little lack of capacity or expertise in that as well, especially for the small systems. There are not a lot of resources or tools available for that. So I acknowledge that. Thanks. Yeah, so we'll just discuss how to overcome these challenges. And first of all, any system that is planning to do anything related to infrastructure, they have to assess their own needs. you have to identify your pain points. Obviously, a lot of people said aging infrastructure, compliance issues, workforce. So these you need to identify those issues and then prioritize areas where smart tech can have your biggest impact, can have leak detection, energy optimization, resource utilization, or training of like workforce as well, or like improving efficiency with the existing workforce. You need to plan strategically, develop a phased roadmap for technology adoption, start with IoT sensors, then add automation, and then align your upgrades with long-term goals, compliance, sustainability, energy efficiency. Because as we saw that a lot of people said that cost is a major concern for them. So developing a phased approach would be a really good start to implement these smart technologies. And then sometimes there are opportunities from EPA, USDA, and there are sometimes loans for these kind of projects as well. And then the best part I find is like you can partner with universities or local environment groups or local groups for low cost pilot projects. And all of that comes to like training your staff how to use that technology, providing them hands-on training for like reading those graphs, making informed decisions from with the help of those graphs, because the data is useless if you're not like capitalizing on it. So there's really it is really important to train your staff on how to use that technology. And then we need to have obviously there is a resistance to change. We all feel like that, and we all are like really susceptible to that. So we need to foster a culture of innovation and adaptability, especially with the new tech, because it is going to be here sooner or later. Yeah, well, again, just the basic benefits and like how we can use this technology. We can optimize our resource use. We can monitor like water quality, resource consumption in real time. We can have energy efficiency approaches with these sensors, with the smart meters, like and integrate energy efficient equipment as well with the aging infrastructure. If we want to like change an infrastructure system, we can make it more energy efficient while we are changing it, or while there is time to change that component of equipment. Also, again, pairing renewables with smart controls for maximum efficiency to reduce your high demand charges from your utility. You can install renewables and then pair with those sensors of when the water is to be treated and when your capacity is going to be high, or when your energy use is going to be high. And all that, I feel like engaging with the community is real benefit for this technologies. You can build real-time dashboards and get real-time data through this to the public dashboards to build trust within your community. And you can also educate residents on water conservation and your sustainability efforts or efficiency efforts for your wastewater treatment plant and how you are doing that. Um, Again, collaborating with universities on student-led projects for cost-effective pilot programs. I know and personally have seen that there's a lot of issues with the cost. It's not possible for everyone to do a big project. So the best way I have seen here in Maryland is to collaborate with universities or community colleges. They have usually some sort of engineering programs, and there are always capstone projects each semester. So you can talk with your university or even community college to let them know what your needs are, because these basic projects can be like piloted by the students as well. So it'll make a really great partnership to work with universities and community colleges to install or just get started with a pilot project and see what kind of data we can collect and how we can use it before going into a big project. And then there are obviously environmental finance centers and community organizations that can provide you sometimes free technical assistance for system assessments and technology integration. And also like you can leverage expertise from these organizations for training and funding assistance as well. There's obviously for the EFCN, I would say there's technical assistance, free technical assistance on any topic, and as well as funding assistance support as well. So the best part would say to start with the small pilots and invest on some small sensors and IoT equipment, and then apply for additional resources or funding. So this information and data that we collect, it also builds real-time public dashboards, and through this real-time dashboards, you can provide updates on water quality, system performance, and compliance. And this will definitely build your trust by making data accessible and understandable to the community. And this can play a really big role if you are trying to have a rate increase or something for this. You can educate residents on what you are doing and for on wastewater challenges and solutions that you are implementing, and get their public support for infrastructure upgrades as well as other initiatives. So we'll just briefly talk about like future trends that we have seen. Again, I was really surprised to see the poll that a lot of people have already sensors into their systems. There's a lot, again, technological integration for compliance, the adoption of advanced technologies such as AI, IoT, obviously will have enhanced real-time monitoring and data analysis in future. And we need to adopt these technologies now to like meet those compliance standards effectively. And again, there's a threat of climate variability, and we need to enhance system resilience by having adaptive management and ensuring compliance while maintaining operational efficiency, because these are all critical infrastructure and we need to be serving our community in all these conditions. So we need to build our resilience as well. Again, another future trend that I like to just briefly mention as well. There are other EFCN resources on cybersecurity, which is again because of this IoT connecting to internet. It's a bigger concern that we have seen on the rise these days. So again, there are EFCN resources you can refer back to from the EFCN website. These smart systems are usually designed with robust security features such as encryption, firmware updates, and network segmentations. So they are like isolated. Usually the best systems are isolated just for your plant or just for your treatment plant. And obviously we need to have more like trainings and policies to ensure that all operators understand the best practices for maintaining a secure system when they have these smart technologies. We have our last poll, I believe.
Yep, it's the last one. We have it launched. Give it about a minute. Okay, about another 10 seconds. Okay, so the question for this poll was, how interested are you in using AI or machine learning for predictive maintenance or anomaly detection? Apologies there. 18% said that they are very interested or are already exploring. 63% said they're somewhat interested and would love to learn more. And 19% said not interested, it seems too complex or expensive.
That's perfect. Like this is the next part is just for just basic simple AI tools. So it's really great to see there's interest to learn about basic AI. We'll just talk about like what basic AI can do in your day-to-day routine task and how it can help you. Obviously, there with the time there'll be more enhanced technologies to be implemented into the wastewater treatment infrastructure system as well. So when the time comes, we can talk more about that. But this is just to like reduce your workload, or like how you can efficiently use some basic tools to gather information or messages, or like find information on new treatment technologies, best practices, standard operating procedures, assist in diagnosing equipment issues, troubleshooting and common operational problems for any equipment that you have, or help you draft any reports and summarize operational data, or offer simplified breakdowns of technical concepts that you hear. And it can also help interpret and explain regulatory requirements to you. And then again, basically all these AI tools again need human oversight. You need to read through the text in detail. You can't like just rely solely on AI tools, but it can obviously help in your day-to-day routine task a lot. I'll just share some tools. Uh, so there are different AI uses. One is generative AI uses, and then advanced AI, generative AI you can use in crafting communications and documentations, like ChatGPT. We all have heard about it. It can help you draft professional communication, simplify HR tasks, and like this can also save time for like resource constrained team. We have seen a lot of like small teams are really resource constrained with the workforce, and then it can also help with access to HR policies for the employees and operational manuals that you have for the equipments. And it can enable quick answers for employees without manual searches. It can help you develop some standard operating procedures, or help you learn from them, or how to implement them, and can give you like basic breakdown of like how to implement or refine those standard operating procedures by analyzing existing documents that you have. And then the advanced part of it is predictive maintenance. Again, this is linked with smart infrastructure systems. It can analyze historical data to predict equipment failures with the help of machine learning and prioritize maintenance. So it's just like we will be alarmed or notified like this systems can be or need to be changed ahead of time. And then AI can also evaluate asset lifespans. It can also be helpful in asset management and avoid like failures using historical data, and which can also help like capital improvement plans and budgets. And again, this can also help identify trend and influence in filtration, energy use, or treatment processes to identify and optimize performance and reduce cost. So the basic first tool that I would like to introduce is Perplexity. I personally use this tool a lot because it provides comprehensive answers by synthesizing information from multiple sources, and it offers personalized learning experience, detailed explanation, summarization, and writing. The best part and the reason why I use it is because it provides you actual resources from where it got this information from, because a lot of times AI can give you some fake information as well, and with no references attached to it. So this is really amazing tool that you can use to get some information related to your wastewater treatment plant processes, some regulations, some compliance standards. You can like just type in and get the information either from web, so it will just search through the websites, or some academic. So there are a lot of research papers around the wastewater treatment plant. So if you are querying something about it, so it will explore some research papers as well. So you can click either both, or just click web. So it will give you a really good summary with all the links. And so you can go to that actual website and then read about that more in detail on what it is talking about, or what information you can gather from that resource or that link. So this is really useful to get some information in just quick, timely manner. Another tool or website that I would like to suggest is Google Gemini. It's from Google. It can summarize your email. It can be used for creating structured meeting agendas, or if you are having a meeting transcript, you can like analyze those meeting notes and create something useful from that. And then it is really good in image to text conversion. If you have any old resource that is in just image format or a text, and you would like to convert it into a text. You can upload the images and it will convert into a text really quickly and really accurate with that. This is one of the accurate tools that I have seen from image to text conversion. And again, also to analyze PDF information, you can upload your PDF of any knowledge book or any SOP guideline that you have in PDF or any regulation, and then you can ask questions regarding that as well from dot without reading a 200-page equipment manual, and it will clearly identify which page this information is from and how what it says. ChatGPT, we almost all of us have heard or used these tools. This is again really basic and good tool to translate text from one language to another. It can be really helpful in doing community engagement with the multiple diverse communities and provide multilingual support and communication. And it can also, if you have any website, it can generate content for your website or social media platforms if your system has, to enhance the public engagement. And again, this tool also allows you to like upload PDF or any document that you have, and it can give you response according to that, although it has certain limitations of how many pages you can upload at once. So, and also this also has now an option of search, but I usually prefer Perplexity for doing online searches and gathering information for any research topic that I'm working on. Yeah, we have few minutes, so if you would like to share your story in the chat, or if you're planning to or already have installed any smart systems technology at your wastewater treatment plant, it'll be great to know that what inspired you to make that change, what impact did it have on your operations, and then are there any lessons learned that you would like to share with the community or challenges you face so that others are aware and then they are able to avoid those mistakes and learn from it and implement it in the best possible manner. With that, we have some time for questions. Thank you. And then there's my contact information. It's available inside, so you can reach out to me via this email or the number shared earlier. Thank you. Take it away, Owen.
Yeah. If you want to go back to that last screen, I think we could probably leave that one up just so people have the information through the end. But so we had a couple questions come in throughout. One of the questions was directed when we were talking about La Mesa, and it was, what are the La Mesa monitors monitoring? And then they were wondering if it was monitoring elevation. There was also a follow-up in the same question as La Mesa. Instruments monitor specifically what, such as elevation?
Yeah, so from what my understanding of while reading about this case study on the EPA website, I can provide like links to that as well. It was just like monitoring the flow in the main holes and how, like, obviously, again, the elevation part of it as well, to see like how much flow they'll get within an hour or so.
Okay, awesome. The next question that we got were, what resources exist for coastal communities who want/need to incorporate the risks of inundation from sea level rise and groundwater into their infrastructure assessment methods?
Yeah, I think there are again resources on EFCN website to see or do like climate vulnerability assessment to see what are the like quantify those impacts on in the real terms and then implement any resilience strategy or adaptation strategy with the whole help of this technology. You can obviously get real-time data with the help of sensors and smart meters, and but the first basic step would be to get a assessment done on what the threat is with the help of with the climate vulnerability assessment, which again I believe there is a lot of resources available on EFCN website to basically do that, or reach out to any EFCN network for getting technical assistance if you are interested in that. Then it will lead to a use of smart systems and technologies for like accurately monitoring that and keep monitoring that to make further changes as well.
Okay, awesome. If anyone, that was the last question. There is one more response that someone did send in. If anyone has any other questions, we do have a couple of minutes left. Feel free to throw them into the questions dialog box. Someone wanted to mention that when you were asking about things that they've learned in their communities, to make sure that SCADA, SCADA, can be easily edited. They had an SBR that had cascading changes, and they want to make people aware that you need to be sure that those automatic changes will not be detrimental.
I'm not sure if I understood that question correctly, but if I'm
Oh,
getting
sorry, that
like,
was in response when you were asking people to share their
oh, okay,
things that
okay,
they've. Yeah.
perfect.
Yeah. Give it a second if anyone has any other questions. It doesn't seem like it, so we can wrap up here. A huge thank you to Dinesh for sharing their expertise with us today. Following this webinar, you will receive a follow-up email with the slides from today and a link to the recording. We also ask that you complete the webinar evaluation following the webinar so that you can let us know your thoughts on today's session, as it helps us plan for future webinars on topics that are important to you. So thank you again, and we hope to see you at future EFCN events.
Thank you, Owen.